Our group is consists of 2 people. My name is Fatin Khadijah binti Roslan and my metric number is AA221216.
My name is Amy Farhana Afikah binti Azumi and my metric number is AA220027.
Psychrometric chart is a graphical representation of the physical and thermodynamic properties. Parameters that can be plotted on this chart is dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio, dew point temperature, specific volume, and enthalpy. First one is bulb temperature, is the actual air temperature measured with regular temperature. The horizontal axis of the chart represents dry bulb temperature. These red lines is where you can read the dry bulb temperature. The circled value at the bottom of the chart is the parameters for dry bulb temperature. Next is wet bulb temperature. It's the lowest temperature that can be achieved by evaporating water into the air at constant pressure. This oblique green line is where you can find the wet bulb temperature. The circled value here is the parameter for wet bulb temperature. The humidity ratio or specific humidity or moisture content is the mass of water vapor per unit mass of air. The vertical axis represents the humidity ratio or specific humidity or moisture content. These vertical yellow lines is where you can find the humidity ratio or specific humidity or moisture content. The circled value here is the parameters for humidity ratio or specific humidity or moisture content. Next is relative humidity. It's the ratio of the actual amount of water vapor present in the air to the maximum amount of air could hold at the temperature. This purple curve is lines where you can find the relative humidity on this chart. The circled value is the parameters for relative humidity. Next is specific volume. Is the volume occupied by unit mass of the air water vapor mixture per kilogram. These red lines is where you can find the specific volume on this chart. The circled value is the parameters for specific volume. Enthalpy is the total heat content of water vapor mixture. These blue lines is where you can find the enthalpy on this chart. The circled value is the parameters for enthalpy. Next is dew point temperature. Is the temperature at which air becomes saturated with moisture, leading to the formation of dew. On this chart, dew point temperature can be found by the intersection of humidity ratio and dry bulb temperature. Let's say the dry bulb temperature is 28 degrees Celsius and the humidity ratio is 0.013. Now we have to draw the line for dry bulb temperature, which is 28 degrees Celsius. This is the first step, and then we draw the line for humidity ratio, which is 0.013. This is the intersection from both dry bulb temperature and the humidity ratio line. And then you have to draw horizontal line from the intersection toward the wet bulb temperature parameters to find the dew point temperature. And then we know the dew point temperature is 80 degrees Celsius. Let's do the first question. Given is the dry bulb temperature and wet bulb temperature of air. Dry bulb temperature 30 degrees Celsius, wet bulb temperature 35 degrees Celsius. Determine the relative humidity, specific humidity, dew point temperature, specific volume, and enthalpy. Let's look at the psychrometric chart. And give information is dry bulb temperature and wet bulb temperature. So we are going to draw the lines. I'm going to draw the dry bulb temperature first, which is 30 degrees Celsius. Draw the vertical line. And then draw the line for wet bulb temperature, oblique line at 25 degrees Celsius. At the intersection, I'm going to find the relative humidity. We have to draw a line, curved line, from the intersection to the relative humidity parameters. Okay, and we get for the relative humidity is 64, 66, 68, and then the line is at the 67. That is our relative humidity, 67%. And then we're going to find specific humidity. Is we going to draw a horizontal line from the intersection. I'm going to use the color yellow, orange. Draw a line from the section. Then we get our value for specific humidity is 0.018. Now find the dew point temperature from the intersection. Draw line to the left. Okay, draw the line. I'm going to use pink color here. Then the point is, this is 22, this is 23, 24. Okay, there's a 5 part between 23 and 24. So our dew point temperature is 23.2 degrees Celsius. Write our information here. Now find the specific volume. We're going to draw the line that touch the intersection between dry bulb temperature and wet bulb temperature. This is 0.89, 0.88, 0.87, 0.86. Next, our line is at the value 0.8825 because there are 4 parts between 0.88 and 0.89. And our specific volume is 0.88.25 meter cube over kilogram. Next, let's find the enthalpy. We draw a line that same value and touch the intersection. The line is at 76. The enthalpy is 76 kilojoule per kilogram. Second question is, how much heat is required to raise dry bulb temperature of 100 kg of saturated air from 10 degrees Celsius to 35 degrees Celsius? The hint is find enthalpy. Information given is dry bulb temperature 10 degrees Celsius and 35 degrees Celsius. Firstly, draw the line for 10 degrees Celsius of dry bulb temperature, and then second line is 35 degrees Celsius for dry bulb temperature. The lines are drawn vertically. Then draw another line to connect those two lines so that we can get two intersections. This is the first intersection and this is the second intersection. From these two intersections, we have to find the enthalpy. Now, to find the enthalpy, we have to draw line that touch these intersections. I'm going to use red color and then draw the enthalpy line that touch the intersection at the first intersection. The enthalpy is, this is 38, 29. Enthalpy for 10 degrees Celsius is 29.5 kJ per kg. Then find the enthalpy for the second intersection at 35 degrees Celsius, the bulb temperature. Make sure the lines are touching the intersection. The enthalpy for 35 degrees Celsius dry bulb temperature is 55 kilojoule per kg. Then from back to the question, this is the enthalpy for both temperatures. To find the heat, we put the equation Q equals to M H2 minus H1 from the energy balance equation. Now H2 is 55 kg per kg. H1 is 29 kg per kg. From the question, we have the information for the mass is 100 kilogram. M equals to 100 kilogram. And then put this information into the equation to find our heat, to find the Q. 55 minus 39, and we get our answer is 2600 kilojoule. Is the heat that needed to raise the temperature from 10 degrees Celsius to 35 degrees Celsius. Let's move on with the third question. Which air has the lower wet bulb temperature? For air A, information given is dry bulb temperature at 40 degrees Celsius and relative humidity at 30% RH. For our air B, dry bulb temperature is 30 degrees Celsius and relative humidity is 60% RH. To find the wet bulb temperature, firstly we have to draw the line of dry bulb temperature and relative humidity, and then from the both of the line find the intersection to determine the wet bulb temperature. Let's start with air A. Draw the line for dry bulb temperature at 40 degrees Celsius. Make sure that the line is straight, and then draw a curve at 30% RH, the curve for relative humidity. Make sure that the curve are really touching the scale. From these two lines, find the intersection. I'm going to mark with yellow color. And then, to find the wet bulb temperature, draw an oblique line that touch the intersection. As you can see, between 26 and 25 has 5 part here. 1/5 equals to 0.2, and then the line that we draw is at the scale number 3. 0.2 multiple with 3 we get 0.6. 25 plus with 0.6 we get 25.6 degrees Celsius for the wet bulb temperature at air A. Moving on for air B, the dry bulb temperature is 30 degrees Celsius and draw a line, vertical line at 30 degrees Celsius, and then draw a curved line at relative humidity 60% RH. Make sure that the line touching the scale and really precise. And then find the intersection between the two lines. Going to mark with this dark color, and then draw an oblique line that touching the intersection. Between 24 and 25, I need 7 part of same length. So 1 divided with 7, we get 0.143. Since our line is at the scale number 1, 24 plus with 0.143, we get 24.143. So for our wake up temperature for air B is 24.143 degrees Celsius, and then compare the wake up temperature for air A and air B, we get that air B has the lower wake up temperature. That's our final answer.